is on triangles. Alright, when you're doing one of these proofs, what I would suggest you do is first start with a picture. So after you write your given down, all we're doing is literally recopying what's written in the given line. And writing given for the reason. And so when we get to the rest of the proof, then the first thing I do is I look at the picture and I'm looking for one of two things. Something called a shared side, like side SV, is shared between both triangles. That's called a reflexive side, and what that means is it's literally the same side in both triangles, so I can mark it as congruent to itself. And when I do that, I mark it first and then I go to the proof and I say that SV is congruent to SV, and that is called the reflexive property. That's all I can get out of the picture, so now I got to use the given. I read the first part of the given, and it says VS bisects angle RST. What I see is this means it cuts angle RST in half, in equal halves. So if I go over here and I trace out where is angle RST, it's right here, RST. This big angle right here is cut into two equal halves, which means this half and this half are equal to each other. So I got to name that angle right there. If I trace it out, it's VST. So angle VST would be congruent to, and this one is VSR. And how do I know that? Well, I use this idea of bisector because it's written in the proof. I can't use it if it's not written there, but since it is there, I know I need to use it. So that one I'm going to say is a definition of, and a lot of people put segment or angle, they don't know which one is which. These are angles that I'm working with. This is an angle bisector. If you look at the given, that was the first part of the given, but if you notice it also says that it bisects angle RVT, which is over here, this big angle right here, which means that these two halves are equal to each other. You notice I marked it twice because that's the second pair of angles that I know. This one is SVT and SVR. And because it's the same reason, I write it along in line 3 and I don't need to write it again. Finally, I'm down to step 4. What I would say is anytime you get a pair of triangles and if you focus on one of them, you should have 3 things, separate things marked in that triangle. When you have that, you're ready to say they're congruent. So this is triangle STV congruent to triangle SRV. Now the reason is something you'd have to look at a pattern for. It's going to be one of these 4 things at the top. The question is which one is it? If I look at it like this, I see angle, side, angle. It's ASA. And that's a completed proof for that one. Notice how the picture is marked and the proof is written out. The idea is that you do both. Alright, let's move to number 2. So again, after I recopy the given, I can see that I was told that angle B and angle C are congruent, so they're already marked in. I look at this picture and I see an X right here. When I see an X, I think about vertical angles. Vertical angles mean that when you have an X, it creates 4 angles right in here. 1, 2, 3, and 4. And the 2 across from each other, like this one and this one, and this one and this one, they're guaranteed to be equal. It doesn't have to be written in the picture. You would know that automatically. So for our purposes, the angles that I want are the ones that are actually in my triangles, which would be this one and this one. So I just got to label them and put them in my proof. But I know this because of the vertical angle theorem. So step 2 is vertical angle theorem. And then this angle is AEB. And this one, CED. Alright, and then finally, since I got that from the picture, then I'll actually go to the given, and I see that this part about E is the midpoint of AD. I look over here, here is AD. When E is a midpoint, what it means is that this half and this half are equal to each other. So if I mark them in, this half is AE, and it's equal to the other half, which is DE. And since I use midpoint to do that, this is definition of midpoint. And again, I'm down to that point where if I look at the triangle, I have 3 separate things marked in it. And if I trace out the pattern of those things, this would be angle, angle, side. And that means these triangles are congruent. So the important part of this front page is that it shows both examples of the things you can get from the picture only. In the case of the first one, we got the reflexive side just by looking at it, and in the case of the second one, the vertical angles. So you always want to be looking for those things in your proofs, kind of as a first step most of the time. Alright, so let's see if we can go through these other ones a little bit more quickly. I'm actually going to do number 4 first because it's a little bit easier than the others. So again, after writing the given down, I would say look at the picture. Now these 2 sides out here are marked in because we were told that in the given. But what else can I get from the picture? If you look at BD right here, I have again a shared side. This time it's my second pair, so I'm going to give it 2 marks, and I'll say BD is equal to BD, or you can say congruent, it's okay. And this is the reflexive property again. Alright, but that's still not enough because I only have, if I look at this one, I only have 2 marks in the triangles. I'm going to need 1 more. But that's where I use the given. It says BD bisects AC. Okay, this is a segment bisecting a segment. So if I look at segment AC, this line cuts it in half, which means that this half and this half are the same. That's the third pair of sides. So I would write AD is congruent to CD. And this time I used bisector to do it, and these were segments, so this is segment bisector. And then I would look at my triangle and I would see that I have 3 things marked and they're all sides. So our reasoning here is S, S, S. Alright, so then I'll go up to number 3. Number 3 is harder, I guess, because you're not given a lot in the given. But I guess that means it's easier to recopy it. So again, can we look at the picture and find anything? Much like number 4, there's a shared side right here, so that would be a pair of sides we could say are congruent. QS is congruent to QS, and that's reflexive. When you see parallel lines like this, if you notice in the given there's nothing else here, there's no midpoint, there's no bisector, none of that can show up in your proof then. So when we see a pair of parallel lines, it's a giveaway to the alternate interior angles theorem. And the only question is, what angles are alternate interior? they're formed around a diagonal line like this one. For example, if you looked at this thing like one of our old problems like this, the alternate interiors were here and here, and then the other set over here. So you have four angles, 2 pairs each. So what I'm looking for is taking this idea and looking at this picture in the same way. I'm looking for these pairs on opposite sides of this line. So we have one pair here, like that. This one is PQS, and it's the same as this one, which is RSQ. If you notice when I'm writing that, I put angle symbols next to it because it could be something else if you use 3 letters. So I'm putting angles to make sure everybody knows their angles. Alright, and then the other pair is the other side of the line, here and here. This one is RQS. And this one is PSQ. And we got both of those things from the alternate interior angle theorem. So once again, when we look at the actual picture, we focus on one triangle. You have 3 separate things marked in that triangle, and again it's angle, side, angle. So we're ready to call them congruent. And our reason is ASA. Alright, so last one. The last one is maybe a little difficult because there's more than a few triangles in this picture, so we want to make sure we know exactly what triangles we're working with. Over here in the proof, I'm saying prove triangle PTS, that's this one, is congruent to triangle RTQ, that's this one. So if you had different triangles in this proof, you might do the proof a little bit differently. But since you're working with those ones, you've got to go with what makes sense for those 2 triangles. For example, in this case, between those 2 triangles there is no reflexive side, so that's not going to be something you want to have in this proof. But what there is an X right here, and that's an indicator of vertical angles. And the angles we want in our triangle that are vertical are here and here. So this one is angle PTS. And this one is QTR. And that is the vertical angle theorem again. And then finally we need to use the given. It says T is the midpoint of PR. So that means we have 2 equal sides here, and this one the midpoint. So we have a pair of sides here, here. That's PT congruent to RT. And it's also the midpoint of SQ, which means I have a second pair of sides here and here. So that is ST congruent to QT. And because I used midpoint to do that, this is definition of midpoint. So then the last thing I look at here is, again, I have in one triangle I have 3 things marked, and if I trace it out it would go side, angle, side. So for step 4, side, angle, side. Alright, that pretty much covers everything that would be on your proof quiz.